Okay, friends, here we are on page 5. My goodness, this is long and slow, isn't it? Okay. All right, so given the zeros and a leading coefficient of 1, write the polynomial function with least degree. Okay, so given these zeros and a leading coefficient of 1, so this is where we're going to multiply out. So they're giving us the answers and we're trying to find the polynomial. So we're literally going backwards in what we have been doing. So we've got x equals -4, x equals -1, and x equals -2. So what I'm doing right now is adding 4 over. So this is like a little +4, +4, +1, +1, and then +2, +2. And so now I'm going to write my, well, I'm going to write my polynomial in factored form. Okay, so there's my polynomial in factored form. And now I'm going to do what we did back on the first page and multiply this nonsense out. I'm looking at my factors. None of them make a difference of squares or anything like that, so I'm just going to go straight for it. Pick these two. That's plus x. This is plus 4x. Plus 4 at the end. Don't forget that last one there. Let me zoom in here. Okay, so let's see. Clean this up. Those are like terms. And now I'm going to multiply again. This goes back out to what we were doing on page 1. Did I just do that right? Let's see. X cubed plus 2x squared plus 5x squared plus 5x plus 4x plus 8. Okay. These guys are alike, so that's going to be plus 7x squared. These guys are alike, so that's going to be plus 9x plus 8. So our answer is f of x. You could have used anything there. I chose f of x. You could use p of x or whatever. X cubed plus 7x squared plus 9x plus 8. Okay, let's do this all over again. Up here for part B. X equals 4, x equals √3, x equals -√3. Okay, I'm going to subtract 4 from both sides, and that's going to get me this. I'm going to subtract √3 from both sides. I'm going to add √3. Okay, so those are my factors. I'm writing my polynomial in factored form. Okay, so now, do I want to multiply these two together, or do I want to multiply the second and the third one together? I want to multiply these guys together because they are a difference of squares. So this is x minus 4, and then now this is going to be x times x is x squared. If I multiply this out, which I will this one time for you guys, I'm not going to do it on C and D, but I'll show you this time. If I multiply this out, because this is a difference of squares, I can tell it's a difference of squares because I have the same thing twice. This one's negative and this one's positive. So I get an x squared here. I get plus √3x. Now I'm going to multiply these. I get minus √3x. And now here I'm going to get a negative times a negative is negative. I'm sorry, a negative times a positive is negative. √3 times √3 is actually √9. When I go to simplify this, those guys make a 0. So I just said when I multiply in the future, I'm not going to show these middle terms. I'll tell you that they equal 0, but I'm not going to write them out like this because that defeats the whole purpose of being efficient and smart here. So that gives me an x squared back here. This is not minus √9. It's actually minus 3 because the square root of 9 is a 3. And so I get this. What am I doing? Now I'm going to multiply again. Clean these guys up. So this gives me x cubed minus 3x minus, minus 4x squared plus 12. And double check my math there. X cubed minus 3x minus 4x squared plus 12. And I'm just putting things in descending order. That's like having good grammar, math grammar. It's 4x squared minus 3x plus 12. Am I still on my paper here? Let's see. Okay, there she is. Just double checking. Okay, looks good. Here we go again. More practice, that's all we're doing. Okay, so obviously we're gonna get this a little bit harder. Three plus root 2, 3 minus root 2. Okay, so I'm gonna subtract 4 from both sides. And I'm gonna subtract 3. And then I'm gonna subtract root 2. So I moved that, subtracted that. Okay, here I'm gonna get x minus 3. I'm gonna subtract that over. Now I'm gonna add root 2, and that's gonna give me a 0. So now if I write my polynomial using its factors, this just looks disgusting, but it's really a ginormous difference of squares. So these two look really bad. They do. And you could sit here and multiply. You could go x times x times negative 3, x times root 2, negative 3 times x, negative. You could do that, and you'd get a whole bunch of terms, like 9 of them. Or you can notice that this and this are the same, and this are the same, and I've got one negative and one positive, which means that this is a difference of squares. And so if I did x minus 3 times x minus 3, I would get x minus 3 squared. My middle terms will cancel. I'm not going to write all that nonsense out. That defeats the whole purpose of seeing that that's what's going on. And so now I'm going to do my middle terms cancel, and I'm going to do a negative times a positive is a negative, and then root 2 times root 2 is root 4. Now, I still have a lot of work to do, don't get me wrong. That just made it easier. It didn't make it easy. So this thing squared is going to be x minus 3 times x minus 3. And then this is going to be minus 2. Going to keep going here. Simplifying. I'm just bringing that along because I haven't done anything with it. Now I'm looking really at this part right here. I'm going to do x squared. That's x times x minus 3x plus 9 minus 2. That's that minus 2. Okay, so I get x minus 4. And here I'm going to simplify. Those guys go together. These guys go together. So this is minus 6x's and then plus 7. Great. Now I've simplified that ridiculousness, and I still get to go again right here. All right, so just be careful. X times x squared is x cubed minus 6x squared plus 7x minus 4x squared plus 24x minus 28 minus 6x squared plus 7x minus 4x squared plus 24x minus 28. Perfect. Okay. These are so crazy. There's so many places to make mistakes. It just makes good sense to do it more than once. Okay. So I've got x cubed minus 10x squared plus 24 and 7 is 31x minus 28. Is that true? 31. Yeah. Okay. So this is going to be x cubed minus 10x squared plus 31x minus 28. Cool. Well, that wasn't a long problem. It doesn't even fit on the whole screen. Cray cray. All right, friends, let's try it again. Let's see here. So x equals -1, x equals -4 plus 3i. Ooh. Now, here's the fun part. We're testing right here. We want to see if you understand that these guys always come in conjugate pairs, or in pairs we'll call them. So this is 3 plus or minus root 2. Over here, I only got plus 3i. I would never get plus 3i unless I had plus or minus 3i. So we're testing to see if you understand that these guys come as a pair. And so we want to see you write this one out too. Not to bore you with the detail, but if you were thinking about the quadratic formula, which, like, why does this come as a pair? Let me explain. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. To have an I here, that means you had to have had a radical. To have that radical, you had to have had that plus or minus in front of it. So this is always going to be a plus or minus. If there's an I here, that means there's a plus or minus in front of it. There's 2 roots from that, not just one. Same thing back over here. In order to get that root 2, I had to have been in the radical part of the quadratic formula, meaning the plus or minus was right in front of it. So that's why there's a plus or minus right here. I hope I explained that okay for you. Okay, so f of x is going to equal x plus 1. Uh-oh, I forgot to do the one step in between. I'm just doing it in my head, sorry. I'm going to add that over and then subtract that. Same thing here. I'm going to add 4 over, and then I'm going to add 3i over, and that's going to give me my factor, not just my answer there. These guys you want to multiply first. This is a ginormous difference of squares. X plus 1. And so I'm going to multiply x plus 4 times x plus 4. That's going to give me x plus 4 squared. And then now my middle terms would be big and ugly, really ugly looking, but they will make a 0. And then I'm going to do minus 3i times 3i is 9i squared. Close parenthesis right there. What on earth? That I squared, I don't know if you remember, I'll write it up here. I is equal to the square root of -1, so I squared is equal to -1. So we are going to use this fact right here. Okay, so x minus 1, I'm going to multiply this x plus 4 times x plus 4 out. Minus 9, that I squared is going to be replaced with that -1, and I'm going to keep just simplifying madness. Here I'm going to multiply x times x is x squared plus 4x plus 4x. Ooh, look at my ugly x right there. Plus 16, and then this is plus 9. Okay. This goes with that. That goes with that. And I get x squared plus 8 x's plus 25, I think, if I'm not mistaken. Okay, and now I'm all simplified up, and now I'm going to do more. Yay, multiply again. So x cubed plus 8x squared plus 25x minus x squared minus 8x minus 25. X cubed, this and this is plus 7x squared. This one and this one is going to be plus, gosh, I don't know, what is that, 17x? It's really late at night right now. Let's see. Did I do good math? Subtract 3f, yeah. Minus 25. Sorry, it's late at night and I'm just, my eyes are blurry. I want to make sure I'm not doing silly mistakes, but I easily could be. Hopefully I'm not. Let's see. Okay, I feel good about it. All right, let's finish this page off here. Find the zeros, real and imaginary, of the polynomials, and then it gives us a hint and it says to factor. So what we're doing right now is we're practicing what do we do when we're given this, and on page 4, I guess it was, like problems number 8 maybe. Let me see, let me go back and see if I can. problems here on page 8, or I'm sorry, problems like number 8, I should say. We gave you a cubic, but we also gave you a 0. So we actually gave you a starting place. What's happening now is we're giving you a cubic, but we're not giving you a starting place. So you have to know what to do with this, which is like next level hard. So what are we going to do with it? Well, how do we deal with a cubic? This isn't a trinomial. It's bigger than that. We don't know a factor. They didn't give us a k that works. So we're going to have to go back to the old school and try factoring by grouping. So factoring by groupings. Some of you might have used the area model. And what we talked about in my class a lot was breaking this into two binomials, kind of looking at that part and saying, what do those two have in common? And the answer is they have an x squared, so we factor an x squared and we write it as a product with what is left. You're going to hear me say that a lot. Then I kind of cover that one up and I say, well, what did these guys have in common? And that's going to be a -1. And then you write it as a product with what's left over. Now, that's tricky because of that minus. So let's see if I were to do distributive property, that would give me a -x and a +3. So that works. Okay, now, this is a ginormous binomial. What does this ginormous binomial have in common? They both have an x + 3. And if they both have an x + 3, factor that out and write it as a product with what's left over. Okay, so I just did. Now, I noticed right away that this is a difference of 2 squares, which means that it can factor further. Okay, so I just factored it completely. Let's make that a 0 so we can use the 0 product property. We get x equals -3, x equals -1, x equals 1. Sweet. Okay, and then finally right here, let me see. Okay, so, oh, now this one, oh, look at these two side by side. Let's see what we notice about these. So this is a cubic. This is actually a quartic. This one is a degree higher. This one has 4 terms. This one has 3. This one, do you notice that it's missing an x cubed term and an x term? What that means is that this one kind of acts like a quadratic. That's kind of weird vocabulary, but it means that you can factor it. What I mean when I say this one acts like a quadratic, it's like this. We're going to pretend for a minute that it's kind of that one, and we're going to factor that. Except for instead of putting, instead of going x and x to get an x squared, we're actually going to do x squared here and x squared here. If I multiply those, that'll give me an x to the 4th. And now that 45, I'm going to break that 45 down. Look at all the factors, 1 and 45, 3 and 15, 4 doesn't go into it, 5 goes into it 9 times, 6, 7, no, 8 doesn't go into it, but 9 does. Once you get to that side, you're good. So now do any of these add or subtract to give me a -4. These guys right there can give me a 4, hopefully a -4, so I'm going to put a 5 here and a 9 here. I'm going to make that one negative and that one positive. I'm actually not done with the problem though. I'm trying to find all of my zeros. So I need to keep going here. Here I'm going to subtract 5 to the other side. Now I'm going to take the square root of both sides, and that gives me plus or minus √5i. Over here I'm going to get x squared equals 9, take the square root of both sides, and I get x equals plus or minus 3. How many answers did I just get right there? I got 1, 2, 3, 4, and I expected 4 because this was to the 4th. So I'm happy with all of those. So x is equal to plus or minus √5i. These are two imaginary numbers, two imaginary solutions, and x equals plus or minus 3 are two real solutions. So these guys, if I were to go graph this, these would cross the x-axis, and then those would not. Okay, that's the end of page 5. Whew.